This is an amazing honor for me to be presenting the address keynote, the opening address keynote of this conference. Really, a few years back, I would not have imagined that I could be standing in front of you here, especially given the amazing lineup of speakers presenting today. So it's great. And as I was getting here, I was thinking of my first Python conference, which was the SciPy 2013, I think. And I wasn't presenting anything. I just flew there from New York City, where I used to live, and got to meet some of the core developers of Jupyter, NumPy, SciPy, Matplotlib. And I spent the week trying to get up to speed to become a contributor to those open source software. And after a full week at SciPy, on the way back home, I was completely sleep deprived and exhausted, and sure of only one thing, is that I really wanted to be part of that community. This has been an amazing ride, and I just wanted to tell you a few words about this. Before I get any further, let me tell you a little bit more about myself. So I'm a quant researcher. Up until a few months ago, I lived in New York City, working for Bloomberg, and also working as an adjunct at Columbia and NYU. So last year, I relocated back to Paris and founded QuantStack, which is I would say, a software service company. We provide services and consulting on scientific computing and work a lot with open source software. As an open source developer, I mostly work on the Jupyter Interactive Widgets framework and Jupyter Lab. And mostly with regard to the data visualization aspects of it. So BQplot, Py3JS, IPyLeaflet. You may have heard of a bit about this project, and so I'm going to tell you more about it. And also some high-performance scientific computing in C++. So namely Extensor and Zeus. So Extensor is one item that you'll hear about later in the conference. So Johan, who is here in the audience, is going to present this afternoon about this project in depth. I should zoom out. First, I wanted to start with an advice to those of you who are just getting started in their careers or who have not yet graduated yet and are still students. You guys should get involved in open source development as soon as possible. And in two ways, contribute to a large project that you already use, and start something small. Just put some code out there and try to get feedback. In my experience, I've worked with the smartest people, I met the smartest people I ever got to work with in the open source community. In doing so, you will get feedback from people who have experience building software used by millions at the internet scale, and also get to expand and grow in a manner that is not always possible within your organization. If ever you actually feel that you are isolated in your company, laboratory, wherever you work, you're actually part of a much bigger community, and starting to contribute to this software is probably the best career advice I could give to anyone right now. So, for example, you can have a lot of impact. A simple CSS fix in Jupyter can impact tens of thousands of users. And a lot of people will be thankful because this annoying bug that they were observing is not there anymore. This actually may be making the difference in terms of adoption of some key contributor in the future. There is a smooth ramp of complexity from the drop-by contributions to becoming core contributors to major packages. So start small and make simple contributions first. They will be greatly appreciated by the core developers. Also because most of the time they are overwhelmed with the amount of work that they've got to produce and the maintenance burden of these open source software. It's another dimension of growth than climbing the corporate ladder. You don't need to become a manager to grow in your career. There are many other means to become more proficient and recognized in your career. Finally, you will find some of the most inclusive and diverse communities out there. So Jupyter, SciPy, Interact, Django, and Sage. I just wanted to use this picture here because these are the adapters and power outlets that were in use at the last Sage days that I attended. So there were like 20 different foreign accents and power outlets, and everyone was coding and hacking together. And this picture really shows the diversity of our communities. So yeah, get involved now. Now a piece of advice for employers. Let your employees be involved in open source and actually encourage them to contribute to the software that they rely upon in their work. So, and anything unrelated, even in their free time. This gives a new dimension to grow for your engineering team, and if they were frustrated by the lack of evolution, possible growth within your organization because it's small, because you are not growing at the moment, then there are other perspectives for them. And it will also help you recruit people, obviously, ensure the quality of your team. Besides that, I think that everybody now knows that open source is not for crazy hippies, and closed source software is not evil. Actually, open source is the backbone of scientific computing and more. Compilers, interpreters, OSs, scientific libraries, package manager. You cannot afford to redo all of that yourself. So anyways, you are already relying on that infrastructure. And having a relationship, a good relationship with the community that is building that infrastructure is actually critical to your operations. So if some of your developers, some of your engineers are involved with that community, are recognized and appreciated because of their contributions, when something breaks, you will get help from the community much faster than if you had no prior relationship with them. So yeah, it's common infrastructure used by everyone. So Roads of Bridges is actually the title of a study by Nadia Eqbal, and I just wanted to share this quote. Open up your phone, your social media, your news, your medical records, your bank, they're all using free and public code. So what happens when infrastructure breaks? So one example in history was the one of OpenSSL that is key in the operations of banks, healthcare, defense, and they realized after a major security threat, major security issue was discovered in OpenSSL that there was actually only one person working full-time on this software, while there were multi-billion-dollar business relying on it for their operations. So now what is going to happen to you when NumPy breaks because no one's working on it anymore and the quality and maintenance has not been done for years? Same holds for Jupyter, SciPy, Pandas. What happens to you when this breaks? So right now, there is only a handful of developers working on Pandas full-time, and up until last year, there was none. No one was actually paid to do so. And there is still no full-time developer working on NumPy at the moment, even though there might be one in a few months. So the first way to get common infrastructure and roads and bridges is to clean up the road in front of your house, right? And then if everyone does that, you eventually have a street that you can use, that everybody can use, right? But it's not enough, because for significant efforts, such as actual large bridges and highways, you need to organize. We need to organize beyond cleaning up in front of you, of where you live. So this is what the NumFocus Foundation is about, as far as the scientific computing community is concerned. So the aim of NumFocus is to provide an umbrella organization for a number of open source projects so that they can get fiscal sponsorship, in that if someone makes a donation to the project, you have a single organization handling the possibility, all of the fiscal benefits that you may get from making a donation. It's actually really critical that we have such a thing, not only in the US, but also in France. So actually, back in September, when I relocated to France, a number of organizations contacted me as a core Jupyter developers because they wanted to help and maybe give money to the project. And we said, great, please give us the money. But actually, we had no idea how to take that money, because in France, there is no such organization as NumFocus that is able to give a fiscal receipt for that so that they get the tax deductible, so that the donation is tax deductible. And actually, this is not only true for Jupyter, but also any other open source project of the stack. A consequence of that is that there are some of the main open source projects of this ecosystem for which the leadership and the grants are given in the US, while most of the developers are actually in Europe. So we need to organize now. So our actions, so we are currently working with the NumFocus leadership on the creation of an EU branch or a separate EU entity. So we've worked with a lawyer and a tax lawyer, and we got some advice from people who were experienced with these sort of things to actually put together something to get started so that we can start receiving such donations. And also, in terms of community organization, we just started the PyData meetup last month. So on May 17th, we had Travis Oliphant, the creator of NumPy, and Gael Varocco, who is one of the core developers of scikit-learn, give presentations at UPMC. And so hopefully we'll get more events in the coming month. So yes, what next? This is not enough, actually. We are not enough people involved in these organizations, and we actually need help in many different ways. Help organize more events, find venues, give talks, contribute, advocate for this ecosystem behind closed doors, start businesses that provide support for these open source software. There are many ways in which you can help. And yes, please come talk to us if you're interested and if you have ideas. So let's get to another subject about the language war. What happens when you say Java in a C++ conference? And what happens when you say MATLAB or R in a Python conference? Doesn't play well, right? You get booed most of the time. Actually, there was this image that we shared in a blog post recently, which is that in the future, there will be actual wars about which language humans should use to speak to the machines. This may sound ridiculous, but after all, we make war for more ridiculous things already. So it's a concern, right? Because there is no reason for R, Julia, or Python to be in competition. They have distinct communities and advantages and areas of expertise, but there is a lot of duplication of effort that hurts sustainability and could, if there was no such duplication, make the community move faster. So for example, in this area, there is nothing about R that make it a better system to do a package manager, an IDE, or in-browser data visualization tools. And that's why maybe the R and Python and Julia community should work together on such items that are common to and are problems for everyone and can be solved only once. So we need to collaborate beyond language boundaries. So a quick quote that I picked from Jake van der Plas' keynote at PyCon. It's a quote by Fernando Perez talking about his PhD advisor. So my advisor had a heavily customized Oak, Sed, and Bash workflow to manage job submissions and post-processing of C codes for supercomputing runs. So I used her script to run my jobs, and on top of that, has added my own layer of Perl plus a hefty amount of GNU-plot, IDL, and Mathematica. I'm really sorry, but this is horrible. And also, this really sounds a lot like my PhD. So I was already dealing with such horrible workflows. And this is, another fact about this quote is that he was using something like 7 or 8 different technologies and languages, right? So if each one of those had a different package manager, like putting everything together in a reproducible fashion is really, really difficult. So that's where Jupyter comes into play. So what is Jupyter? Raise your hand. I just want you to make a quick poll before. If you have heard of IPython and Jupyter before. All right. Everyone have used IPython or Jupyter. Almost everyone have used the Jupyter notebook. It's about the same set of people. All right, now a tough one. Have used the Jupyter interactive widgets. All right, about half of the crowd. Okay, so you know what this is. So it all started back in 2001 when Fernando Perez was actually procrastinating on his PhD thesis and wanted to start one afternoon hack to make Python better for scientific computing and improve the shell so that he could use bash commands and do some interactive data visualization with the Python shell. So the code that he put together in that one afternoon is still online. You can find it on GitHub. It's called One Afternoon Hack. It's under F. Perez. And this is the start of a story. And the person behind Fernando here is Brian Granger, who has been involved in IPython and Jupyter from the very beginning. He's also one of the two main leaders of the community. But today, the Jupyter team is much larger. So this is a picture from the Jupyter dev meetings of 2015. There is almost everyone here. We're missing Kyle, Kelly, and Paul Ivanov. So I picked the wrong picture, but they were there that day. And it's also a pretty well-funded project. So we've got sponsors from the Alfred P. Sloan Foundation, the Hemsley Foundation, the Moore Foundation, the US Department of Energy, Microsoft, IBM. So a number of institutional and companies that are actually funding and sponsoring the project in various ways, either by contributing development time or by just giving money to help the leadership. So what's the Jupyter Notebook? So it's an interactive browser-based computing environment, so which enables exploratory data science, machine learning, visualization, analysis, and stats, and help you produce reproducible document with a well-specified format containing code, narrative text, equations, images, and visualizations. And the architecture of the Jupyter ecosystem is made in a way that is completely language agnostic, and that the kernel, which is the part of this infrastructure that is responsible for running the code, is very modular and can be rewritten for many programming languages. So there are over 50 programming languages supporting Jupyter at the moment, and obviously everything is open source. So this is a screenshot of the Jupyter Notebook. This is not great in terms of definition. Should probably zoom in, but you can already. That's worse. All right. I'll show it to you later, like a live demo. So where you can, in the same document, have interleave rich text for a narrative, code examples, and their outputs, and some data visualization. So kernels are available for Scala, Julia, Spark, R, Perl, Python, Ruby. They don't all have the same level of support and features, but the basic features are there for all these languages. In terms of adoptions, so back in 2015, IBM conducted a survey of the Jupyter community and estimated that back then the community was about 3 million users. So it's huge. And as an open source developer, when I started contributing to IPython, which was really not to 3 million users, I had not imagined that code that I was writing would impact so many people. Also, I was clearly not as good as a developer as now, and probably grew in competences as the project grew as well. So in terms of who is involved in this community, we have a good share of data scientists, which is about 29% of the crowd, students, scientists, researchers, developers, engineers, and people working in education. There is another means to measure adoption. If you go on GitHub, which actually renders the notebook format, they actually list all the notebooks that they've got on their website, and there is around, so last time we checked, there were 600,000 notebooks shared on GitHub and growing. So this gives a good idea of the adoption. So yeah, Jupyter is probably a good display of a healthy open source project. So there are a few commercial offerings for Jupyter. There is most of the cloud service providers, Google Data Lab, AWS, Amazon Web Services, Microsoft Azure. CoCalc and Wokari are smaller, but also very involved in the development of the software. So there are some other large-scale deployments. So educational at UC Berkeley, Cal Poly, San Luis Obispo, University of Sheffield, ETH Zurich, and so the National Energy Research Scientific Computing Center, the San Diego Supercomputing Center, Minnesota, the CERN, the Wikimedia Foundation, et cetera. There are some really big deployments of Jupyter and the multi-user server Jupyter Hub out there, and some of them are actually deployed at the internet scale. So it also allowed enabling reproducible science. So I don't know, who in this room has heard of the LIGO project? Okay, it's probably half the crowd. The LIGO is the name of a physics experiment that was meant to measure and see whether gravitational waves were just a theory or whether they could be observed in practice. And right after they put together their experiment, they actually measured for the first time gravitational waves back in 2015. So just a month after they plugged in the device. And this is probably one of the papers that is going to be the most cited in the next 20 years. I would not be surprised if some of the authors got a Nobel Prize for this. And what's amazing about it is that the entirety of the research is made available on GitHub in the form of Jupyter notebooks, and so that you can actually also run it in Binder, reproduce it, tweak the results, and play with the result, and we do all the charts and graphs. So from the exploratory analysis to the presentation, Jupyter is actually displayed. Jupyter, but also the other software of the ecosystem are actually being used for the LIGO project. It also is used for reproducible journalism. So BuzzFeed is not just about the 10 most underrated movies of all time. They also do some actual proper journalism, and some of which is data-driven. And every time they actually play with some data at BuzzFeed, they also share the Jupyter notebooks on their GitHub account, and you can play with the result and reproduce all of this based on their material. So it's more than just notebooks, actually. While the notebook is the most visible item of the Jupyter ecosystem, Jupyter is also a file explorer, a text editor, and a console. And all these things together are the different tools and means that as data scientists and engineers we use to interact with the data. So actually we really wanted to put all of this back together, and this is why we started the Jupyter Lab project, which is a complete rewrite of the front end into a single interface that encompasses all of this and provides the same type of experience as a desktop environment with tabs, multiple windows within one browser window. So in this image, you can actually see a terminal, a file explorer, some of the components that I listed earlier, but all in one. I'm really sorry about the definition of the screen. It really looks great on my screen. Actually, I was planning on a demo. I don't know how much time I have left. 10 minutes? Okay, so I'm going to show you a bit of Jupyter Lab, just with one hand, since I need to hold the mic. So here, you see a classical notebook, and you recognize the usual notebook interface with some images, code, some rich text formatting. So this is a regular Jupyter notebook, but it's not quite the same thing as what you used to use, unless you already used Jupyter Lab. There are a few other items that we can unfold on the side, such as a file explorer. And for example, if you want to display a figure, you can just take it and drag it on the side, and then you can just open the image. So here on the left, you have a regular file explorer with drag and drops. You can open a file or open it with a different type of editor on a right click. So this, in this example, also you can arrange your workspace in a richer fashion by just dragging things around and making a nicer type of layout for your workspace. So this applies to this applies to pretty much anything. You could be running a terminal, measuring the most CPU consuming processes in JupyterLab, and have something that provides an experience very close to that of a desktop application in your web browser. This is actually really important for those who are working with supercomputing environments and usually had to work with some SSH server on the one side, upload files with another means, etc. Here, JupyterLab actually proposes a single interface for all of these use cases. So the other thing that I wanted to talk about really briefly, since I don't have so much time left, is the use of interactive widgets. So JupyterLab and Jupyter and the notebook are not just about code and output. You can actually do much richer things in the web browser than just that. For example, and this is, I'm sorry. So when you use the notebook and you hit 9 times 9, and last time I checked, it's still true, still 81, what happens here is that I type down some code in the document. This modifies the model for the Jupyter notebook, and execute request is sent back to the kernel that outputs some results, sends a message back to the front end, and that displays the front end. So there is a quite involved and complicated set of things that happen when I hit Shift-Enter in the notebook, right? Although this is almost instantaneous. The one thing, so this loop here is called the read eval print loop. This is why we called this the terminal early on the REPL, read eval print loop, right? So the main problem is that here the bottleneck in that loop is me typing the code. If I want to explore the result of that variable only with one hand, it's even worse, right? 8 times 8. It took me like 2 or 3 seconds to type down 8 times 8 instead of going back to the code, modifying the parameter. While I could be smarter and define a function and try to see the value of the square function for different values, but this is still cumbersome and I'm still the bottleneck in this operation. So widgets are actually meant to make this loop faster, where I can actually explore the result of the square function in a more interactive way. Obviously, this is not the sort of application that you want to do, but here we've got everything. We've got a visual, a small GUI component that is displayed inline in the notebook that allows you to interact with the data. But what are widgets? Widgets are actually objects that, when displayed in the notebook or elsewhere, are replaced with a visual component that you can use to interact, such as a slider, right? And you can bind widgets together and make them reflect the same values. There you go, right? So more importantly, Jupyter Interactive Widgets are not just a set of controls such as drop-downs, sliders, and checkboxes. They are a framework upon which you can build. And we actually have built pretty amazing things on the top of it for data visualization. So since I have only 3 minutes left, and Stéphane is going to kick me out very soon, I just want to talk real quick about, for example, BQplot, which is a Jupyter Interactive Widgets library that implements the grammar of graphics constructs. So there are some grid lines that are not showed here because of the brightness, but it actually looks a lot like ggplot. And as I modify, right, so apparently I have got some more time. So as I move, as I change the values of the, as I change the values of the x and y, I should enter, yeah, of the x and y attributes of the scatter plot, I see this reflected in the front end, obviously. So this is actually really helpful for like interactive exploration from the code and from the interactions of the mouse. Or the same holds for actually for the other attributes such as scales, axes. So if I set the minimum of the X scale to 4, for example, here the range is not going to be computed anymore from the data, but reflect the fact that I have selected 4 as the minimum. You can also use, if I set it back to none, this is going to be back based on the data again. Or you can edit the figure, setting the label or whatever. You can also use bqplot figures as input widgets. So quick example here, where I use a bqplot figure as a means to select an interval. And this is really important, for example, when you are dealing with time series analysis, where you may want to do this analysis on a prescribed interval. And most of the time, the way you would do this is by setting the min and the max of the interval from your code, or having, if you're using some fancy library for visualization, having a brush interval. In this case, actually, just the position of the mouse is going to be determined completely the width and the center position of the interval. So the height of the mouse is going to correspond to the width of the interval, and the center and the horizontal position of the mouse is going to control the position of the center of the interval. And you can see what are the selected items in the line. So, or you can use this to hand draw. So here I changed the interaction and made this figure a means to input a function. So if you are dealing with some model that takes a function as an input, and you are trying to use some sides and exponentials and linear components just to see what would be the outcome of your model with this or that input, or you can just draw it, that's even faster. So again, the means here, the goal here is to build and to fasten this bottleneck in the read eval print loop that you are. Or you can do even worse than that. You can make a scatter plot and move points around. So let's take here the scatter plot. I have a super fancy model that actually corresponds to computing the means and done in Python, and I can just pick a point and move it around. So if you want to go if you want to know the actual behavior of your model when you just change one point, this is a good means to do this. Don't do this for your papers though. Just for to show off this, you can actually use bqplot to build really sophisticated web applications, including animations and all. So in this example, we are reproducing the very well-known Wealth of Nations data visualization that's been displayed in a number of tech talks. So if I just hit play here, I'm going to see an animation of the evolution over time of the income per capita and life expectancy of a number of countries in the world. I can just pause it and hover on a country and see the name of that country. So there is some bug here. Okay, that would be the United States, so which were actually pretty, one of the richest countries in the world already in 1913. Right, but more than 2D visualization, we actually can use this to do some 3D. So here's a quick example of a clickable surface that you can display in the notebook using the Py3.js library. So Py3.js is a set of Python bindings for the 3.js JavaScript library that makes use of the WebGL technology, so GPU accelerated graphics in the web browser. But again, everything here is a widget, from the camera to the surface and the position of the lights. Every single one of these items is actually an object synchronized between the front end and the back end, and can be modified from your code or from a callback that reacts to your interaction in another location of the UI. So for example, here I have a picker that allows me to add a few points, and I can retrieve this information from the Python code. So which makes it a really useful tool for data interaction. Or you can use Py3.js to display some, like for example, rich, some complicated parametric surface, right? Since Py3.js is built upon the Jupyter Interactive widgets, they are very easily interoperable with it. So you can just wire a few of the attributes of this parametric shape with slider values, and now you can make deformations of your shape and see how this would impact its visual aspect. So Py3.js, BQplot, oh, that's not what I want. Leaflet is another one, which is a means to display maps inline in the Jupyter Notebook, draw on it, visualize GeoJSON or layers that are binary on the top of maps. So IPA Leaflet is actually a bindings between Python and Jupyter on the one side and the Leaflet.js JavaScript library. So you see that this is really a powerful means to bring all the power of these JavaScript visualization libraries to your Python workflow. So if you know a new one for which there is not a set of bindings already, like some data-driven pink rabbit, you can just pick it online and just make widgets out of it and have your data-driven rabbit displayed in the notebook and reflecting the set of your, reflecting your data set. So another benefit of using JupyterLab here is that it has this richer layout, and I can just tear out one of the output and make it a different tab so that now it's always displayed on the side and I can continue modifying the states of the widget from my code, right? Another benefit that I won't be demoing right now because of the lack of time is that we are moving more and more towards making the Jupyter interactive widgets independent of the notebook environment. So for example, if you put together an application using the widgets and a data visualization that you like and you want to share with the world, now you can just hit save with the widget state and save the notebook with the widgets, and that is going to be rendered on NB Viewer, or you can just embed the widgets from a context menu, and it will provide you a copy-pastable snippet of code that you can just paste into your blog, web page as a researcher, and if this parametric surface or map is the result of some crazy analytics that you made, you can just share it with the world and they will see it as you saw it in the Jupyter Notebook. So if you just go to jupyter.org/widgets, you actually see a few of those. For example, so this is the actual jupyter.org webpage where we have a gallery of BQplot, IPA Leaflet, Py3.js, and the very same graphics are actually available in the website live. And the next steps for the future of the Jupyter widget infrastructure is that while this doesn't speak to a kernel, we are soon going to enable complete web applications deployable from the notebook that are actually talking to a kernel using the MyBinder infrastructure. I should get back to the presentation. So truly what Jupyter is becoming is the HTTP of scientific computing. And why? It's that beyond being an implementation of an interactive development environment, Jupyter has well-specified communication protocols, file formats, serialization formats, and actually a good specifications matters very often a great deal more than any implementation. So if you have, if you want to write an alternative implementation of any of the components from the front end to the back end or on your kernel, you will, if you comply to this standard, benefit from all the other components of the Jupyter ecosystem. And this is true for any programming language. And this is, so Jupyter is common infrastructure for R, Python, Julia, Octave, Scilab, and whatnot. And this is true from exploratory analysis, data visualization, and in a language agnostic fashion. So what's missing now? Well, we have abstracted the interface to the reports, but that's not everything. Okay, just 2 minutes. First, we have a lack of interoperability between the language of scientific computing. Data structures for data science are not interoperable. A data frame in R is not the same thing as a data frame in Python, and it's very difficult to make them work well together, even though they correspond to roughly the same concept. They have very different semantics, serialization formats, and everything. So we really need to converge on those and have a common native implementation of the data structures for data science. Now, another thing that is really a problem is the scalability gap. When you are doing all your computation in memory with pandas and NumPy, it is rather simple. But then if you need to scale up more and go to a distributed computing framework and go deal with database calls, then you have a you have a gap. You meet a cliff here of complexity, and because it's not, you're going to have to rewrite everything you've done with pandas to use this other framework. So we need a common way of operating on data, whether this is an in-memory data representation or something backed by out-of-core computations or database calls. And so this is why we decided to work on this project, and I announced the Extensor project that will be presented in depth this afternoon, and is meant to solve this scalability gap and the problem of having common data structures for all the languages of scientific computing. Last but not least, I just wanted to make a small community announcement here. In August, from the 22nd to the 25th, we have the JupyterCon conference in New York City. So tutorial talks, development and industry training. So if you missed a reason to travel to New York City, here's a good one. And you will spend the week working at Jupyter, which is even cooler. So thank you.